NEET Model Exam 2025 Physics. Answers from question number 36 to question number 40. Question number 36. A xenodiode having breakdown voltage equal to 15 volt is used in a voltage regulator. Circuit as shown in the figure, the current through the diode is. Okay. Now, we need to find out what is the current which is flowing through the diode. See, this is a point of juncture where the current flowing through 250 ohm resistance is nothing but I. Through the xenodiode is I2, right? Through the xenodiode I2. And through 1K is nothing but I1. So by using Kirchhoff's law, we can write I, which is equal to I2 plus I1. What we need to find out? We have to find out the value of I2. So I2, which is equal to I minus I1, right? So what are the things we need to find out? We need to find out value of I and then I1. And finally, we will be finding value of I2. That is a current which is flowing through the diode, xenon diode, right? Now, let's go and find out. See, first we'll see what is the current which is flowing through 250 ohm resistance. 250 ohm resistance is having potential difference that is nothing but CV by R, right? I, which is V by R. Potential difference is nothing but this is 20. Here, this is 15. 20 minus 15 divided by is the resistance is nothing but 250 ohm, which is equal to 5 divided by 250, which is equal to 1 by 50, which is equal to 0.02 ampere, or this also can be written as 20 milliampere. Similarly, let us find out what is the current which is flowing through 1 kilo ohm resistance. What is the current? That is taken to be given according to the diagram. That is I1. The potential difference across this 1K ohm is nothing but actually 15 volt divided by, and its resistance is nothing but 1000 ohms, which is equal to 15 milliampere, right? Now, what we need to find out actually, current through the diode, we need to find out. Current through the diode, that is I2, which is equal to I minus I1. The value of I already we found. That is 20 milliampere minus I1 is nothing but minus 15 milliampere. So finally, I2, which is equal to 5 milliampere. So correct answer for question number 36 is nothing but option A. Question number 37. A pipe of length 85 centimeter is closed from one end. The number of possible natural oscillations of air column in the pipe whose frequencies lie below 1250 hertz are. Okay. So one pipe is given, one side is closed. Okay, closed organ pipe whose length is 85 centimeter actually. So that is a thing with 0.85 meter, right? And see, we need to find out the frequencies, natural frequencies, which will be below 1250 hertz. Okay. First, for a closed organ pipe, for closed organ pipe, for closed organ pipe, let us write the formula for fundamental frequency, that is F, which is equal to V divided by 4L. V divided by 4L, where V is nothing but velocity of sound in air, which is taken to be 340 meter per second divided by 4 into length is nothing but 0.85 meter. When you solve, we get 100 hertz is the answer for fundamental frequency. Okay, now next we need to find out the condition for natural frequencies. Okay, so the natural frequency that has to be occurring in a closed organ pipe is natural frequency. Okay, the natural frequency that has to be occur in closed organ pipe is given by Fn, which is equal to 2n minus 1 into fundamental frequency. Okay, where n can be from 1, 2, 3, 4, 5, 6, etc., etc. Right? Now, for f is equal to 1, we'll get answer as 100 Hertz. F2, if we just substitute, we'll get 300 Hertz. F3, we will get 500. Okay. F4, we'll get 700 Hertz. F5, we will get 900 Hertz. Okay. F6, we'll get 1000 Hertz. Okay. If you just substitute for F7, it will be more than 1250 Hertz. So the number of possible natural oscillations or frequencies is nothing but number which is equal to n, which is equal to 6, total number which is equal to 6. Okay. Now the correct answer for question number 37 is option C. Right? Question number 38. A uniform cylinder has a radius R and the length L. If the moment of inertia of this cylinder about an axis passing through its center and normal to its circular face is equal to the moment of inertia of the same cylinder about an axis passing through its center and perpendicular to its length, then what is the relation between L and R? See, this question is given like this. Let us take this is one cylinder, okay, whose radius is nothing but R, whose length is taken to be L. Okay, let us assume like this. Now, they are given two moment of inertias will be equal. That is, one is through the axis which is passing through its center like this. So let us take that is I1. So this value by the formula we know mr square by 2. And the other one, the second one, they have asked to consider along the line which is passing through the center, but the perpendicular its length is. So let us take this is taken to be I2. Its formula is given to be actually ml square by 12 plus mr square by 4. And the given condition is these two are equal. These two moment of inertia are equal. When we are equating this, we'll get mr square by 2, which is equal to ml square by 12 plus mr square by 4. Right? Now, when on equating, we can cancel out all m. Okay, we'll get r square by 2 minus r square by 4, which is equal to L square by 12. Okay. So when we solve this, we get r square by 4, which is equal to L square by 12. Right? So when we cancel this, we get L square, which is equal to 3r square. So L, which is equal to root 3r. Then correct answer for this question number 38 is correct option is option B. Question number 39. The value of electric field inside the capacitor is 50 volt per meter. If a dielectric material of dielectric constant 6.5 is filled between the plates of a capacitor, then the magnitude of polarization is. Okay. So we need to find out polarization. The formula for polarization P, which is equal to psi into E, where psi stands for susceptibility and E stands for electric field. Already we know electric field E, which is equal to actually 50 volt per meter. So if we know the value of psi, we can find out what is the value of what? Polarization. So in order to find out this, we have already a relation between dielectric constant, that is epsilon r, relative permittivity, epsilon r, which is equal to 1 plus, right? This epsilon r, that is dielectric constant, is given to be 6.5 minus 1, which is equal to psi. So psi, which is equal to 5.5. So we got to know the value of psi, and we already know the value of E. So polarization P, which is equal to psi into E. Psi value is given to be 5.5 into this is 50. The total value, that is nothing but we'll get 275. So polarization value is nothing but equal to 275. So correct answer for question number 39 is nothing but option C. Question number 40. Three blocks of masses 5 kg, 4 kg, and 1 kg respectively are in contact on a frictionless table as shown in the figure. If a force of 25 Newton is applied on 5 kg block, the contact force between 5 kg and 4 kg will be. Okay. So as shown in this figure, the three blocks are there. So the forces applied on 5 kg block is 25 Newton, right? Everything's right. Now, what we have to find out? First, in order to apply equations of motion, let us find out the acceleration of all the three blocks together. So acceleration A, which is equal to the net force divided by net mass. Okay, net force divided by net mass. Net force which is applied is nothing but 25 divided by net mass is nothing but 5 plus 4 plus 1, which is nothing but 25 by 10, which is equal to 2.5 meter per second square is the acceleration now. Now, what do we need to find out? We need to find out what is the uh, contact force between 5 and 4 kg. Okay, we need to find out between 5 kg and 4 kg. What is the contact force between 5 kg and 4 kg? In order to do that, let's do this. Now, see, I have taken this 5 kg block. 5 kg block, right? So here the force which is being acting is nothing but 25 Newton is acted here. This is 5 kg. And for this, there will be some reaction. The same reaction should be there for even for 4 kg also. So if we find out the value of R, then rest of the things is over. Now, this is moving with an acceleration that is nothing but A. So by applying equations of motion, we can find out that is the force is applied minus reaction R, which is equal to M into A. Force is applied is nothing but 25 minus R. We need to find out mass is 5 and its acceleration is 2.5. So 25 minus 12.5, which is equal to R. So R, which is equal to 12.5 Newton. So this is the contact force between 5 kg and 4 kg. So correct answer for question number 40 is nothing but option A. We'll see in the next video.